Okay, here we are again. And today we're going to explore how do you factor a quadratic expression. And so we'll use this later on as we try to solve quadratic equations. This is a great technique to be very fluent in. So we're going to start by how do you factor a quadratic where the leading coefficient is just 1. So first of all, what do you know about a quadratic? Do you know that it is, well, let's go ahead and fill this in. A quadratic expression is one where the term with the highest degree has a second degree. Okay? Frequently, these expressions have 3 terms. One that is kind of like an x squared, a second degree term, a first degree term, and a constant term, some value c, and that c can be any number without a variable. Okay, so if you see something that is in that form, for example, x squared minus x minus 6 would be an example of a quadratic that can be factored using this technique. So let's take a look. If our constant term is positive, then we're going to use this rule. We're going to always use that first rule of factoring, which is what? We always look for a GCF, okay, greatest common factor. Sometimes we'll find one, but oftentimes when there's nothing out in front of this x squared term, then there is not one. But you want to always be in that practice of looking for a greatest common factor. Okay, then what we're going to do is we're going to open up 2 sets of parentheses. Okay, just like this, 2 sets of parentheses. And we're going to put an x in the front of each set. X, x. Okay, if you happen to have had a GCF, you would have put it outside the first set of parentheses, but we don't have one. Okay, so next we're going to determine the 2 factors of the constant term that add up to the coefficient of the linear term. And probably for this, we might want to look at an example. Let's go ahead and pull this example from the bottom up and play with that one. Okay, where we have a positive constant. We want to think to ourselves, what 2 factors of 6 add to make 5? Forget this negative piece right now, okay? What 2 factors of 6 add to make 5? And if I am not really sure, I might think about listing the factors of 6. I'll start with 1 and 6. Okay, that does not add to make 5. And then there's also the set of factors 2 and 3, which we know does add to make 5. So we put the 2 and we put the 3 in the back end of those parentheses. We know that the 2 and the 3 will multiply to make 6. We know that the 2 and 3 will add to make the 5. We know that to get something positive out here and multiply together, it can be either 2 positives or 2 negatives. What we're always going to do to determine what signs go in the parentheses is look at this sign right here. And that's going to determine the signs in the parentheses. These signs will always have to be the same to generate a constant term that's positive. They can both be negative or both be positive. They'll be whatever sign this is. Okay, so if this is positive, these must be the same sign. Okay, so they must have the same sign. And that sign will be that of the middle term. Okay, so now we're going to multiply these 2 things back together. I take that x minus 2 and x minus 3, and I multiply that back together. Use that FOIL method or distribution, right? X times x is x squared. X times negative 3 is negative 3x. Negative 2 times x, negative 2x, and negative 2 times negative 3 is positive 6. If I add this, x squared minus 5x plus 6, oh looky, we got the same thing back that we started with. Fantastic. Okay, so that always helps us check our work. Okay, so what happens if we have a case where the constant term is negative? We have to make a couple of adjustments here because we know that when we open up our two sets of parentheses, after we check for a GCF, right, we go ahead and put that x in both. But this time we're thinking about what are factors of this number that subtract to make whatever the coefficient is to this x, okay? So let's think about the factors of 6, and we think which of these pairs of factors, 6 and 1 or 2 and 3, subtract to make 1. We know that that's 2 and 3 again, but this doesn't factor exactly the same because of these sign differences. To get something negative, I need a positive and a negative term multiplied together, right, to get something negative. So one of these has got to be positive while the other one is negative. And how do you determine which is which? Well, if you don't choose the right way, you're not going to get the same outcome. So you know you're going to have one positive, one negative. Whichever one of these numbers is greater, we'll take the sign of this middle term, the linear term. So we know that the 3 is greater than 2. It will take this negative sign. So this takes the negative sign, and the other one will have to take the opposite sign. In this case, the 2 will be positive. Okay, so let's go in and fill in these notes. Determine the two factors of the constant term that this time subtract to the coefficient of the linear term. These factors will be in the back of each set of parentheses. They must have different signs. And the larger factor will take the sign of the middle term. All right, so let's take a second and try these examples that are down below here. And we've already done one, but let's talk through how to do these examples. Now, if you feel like you can do this without the coaching, pause the video, try it, and see if you get the correct answer at the end. All right, here we go. We already did this one. Let's try this one. Notice that we have a negative here. All right, so we're going to open up our two sets of parentheses, putting that x in the front of each. And with this negative here, this says I want to think of factors of 5 that subtract to make 4. Forget the negative here at the moment. Okay, so what are the factors of 5? Well, there are only 2 factors of 5. So one of these needs to be a 5 while the other one is a 1. Okay, so now what I want to do is choose the right sign to go in the right place. Remember, with a negative back here, you've got to have one of each sign. All right, so which one goes where? The larger of these two numbers takes this sign. So my 5 will be negative while my 1 will be positive. All right. Let's come over to this one. All right, so I've got x squared plus 9x plus 18. Open up your two sets of parentheses, x in both. All right, and now we're going to look at the 18. Thinking about factors of 18 that add to make 9. Okay, if I'm not positive, I might think of listing the factors of 18. Start at the beginning, 1 and 18, 2 and 9, 3 and 6, and I think that's it. So looking at this list of factors, which of these add up to make 9? We know that's going to be 6 and 3. And then we know they're both going to have the same sign, but which sign? We come back and look right on this one to determine the sign. They'll both be positive. Okay, well done. Next one, let's go ahead and put our parentheses out. Look for the GCF. It's not there. X's in the front of each. Okay, thinking about factors of 12. Let's go ahead and list our factors of 12. 1 and 12, 2 and 6, 3 and 4. That subtract to make the coefficient of x, which is 1. 12 minus 1, nope. 6 minus 2, nope. 4 minus 3, we have a winner. 4 and 3 go in the back here. Great. Now, which one goes which? The 4 is larger than 3, so the 4 will take this sign, the positive, while this 3 takes a negative. Okay, so this is really in a nutshell how to factor quadratics that have a leading coefficient of 1. Many students are good with this. We're going to transition into how do you factor quadratics where the leading coefficient is not 1. That's where a lot of students struggle.